Hi, this is Judy Warner with the OnTrack podcast. Thanks again for joining us. Once again, I have another amazing guest for us who is the go-to guy in PCB laminates. I am with Chris Hunrath today. But before Chris and I get started, I would like to please invite you to subscribe or to favorite us on your RSS feed. Or you can connect with me personally on LinkedIn. I share lots of stuff relative to engineers and PCB designers. And on Altium, I'm at Altium Judy, and Altium is on Facebook, Twitter, and LinkedIn. So please give us a subscribe and a connection, and we'd love to interact with you and hear more about what you'd like to hear on this podcast. But I'm sure you're going to enjoy today's guest. Chris is the VP of Technology at Insulectro, and I'm going to let Chris go ahead and tell you a little bit about Insulectro for those 3 people on the planet who might not know who Insulectro is. So welcome, Chris, and tell us about Insulectro.
Okay, thanks. So yeah, Insulectro has been around over 50 years. We supply materials to the circuit board industry, actually multiple industries, but mostly we've been focusing on electronic materials. Everything from laminates, prepregs, flex materials, copper foils, conductive inks, different kinds of plastic substrates used with conductive inks, process chemistries, imaging materials, drilling materials, lamination materials. So we are, we have 11 stocking locations. We just opened one up in Toronto, stocking location there, and we have 9 branches. So I'm based in the San Jose branch in the Silicon Valley area. So that's a little bit about Insulectro, yeah.
Yeah, nothing going on there in San Jose.
Lots, yeah. So the San Jose facility is one of the 4 branches where we do fabrication on master sheets and master rolls of prepreg and laminate. We do cutting, tooling, vacuum packing. We'll also do that on the lamination materials, the release films and the press pads and things like that. So we do that in 4 branches.
I'm going to ask you more about that later because you just told me about that yesterday, and I had no idea you guys did that. Actually, I saw you more as a distribution channel. So, but before I ask you about that, why don't you give us a little bit of background on your history, sort of in the industry, and how you came to this. I always say no one does this on purpose unless you're an EE, right? So. Yeah,
so those printed circuit boards, yeah. Yeah, those of us who got pulled into the industry, been here a long time. So I started actually back in 1983. I was going to school for chemistry, and one of the shops back east, actually New Jersey, was looking for someone to work in plating on the night shift. And the rest is history, as they say. Mm-hmm. I got pulled into the business. Next thing I knew, I was coming to California to work with our sales team. So that's how I got started in this. And then I joined Insulectro in 2001, and it's been great, being with this company. It's so many different materials that we get to work with, and so many different customers. So it's been
Well, I think you're a familiar name and face in that you being the VP of Technology, but you're also, at trade shows and stuff, you present a lot and are really articulate and, sort of explaining the technology of laminates, because it's gotten a lot more complicated than it used to be back in 1983. I started in 84, by the way. So, but yeah, it used to just be, get some FR4 and some prepreg and you're off to the races, right?
Yeah. Back then it was FR4 and polyimide.
Polyimide, right.
Yeah, true. A little side note, actually the company I worked for made multi-wire circuit boards. So we also had an adhesive to embed the wires in. That's a whole other story for another time.
Yeah.
But yeah, primarily it was FR4 and polyimide. And now there are so many different materials. And then if you add the flex materials on top, there's a lot to work with. It adds a lot of complexity, but also a lot of opportunity. I mean, electronics are going into everything.
Everything.
And we're seeing that with our printed electronics products as well. A lot of interesting applications. From wearables to medical to consumer electronics. So that's been pretty cool to be a part of that as well.
Yeah. So tell us about what you're seeing kind of on the front lines of sort of current technology and marketing trends that are having an impact on laminate suppliers that ultimately, since our audience here is mostly engineers and PCB designers, how that's sort of flowing down and what the impact is.
Okay, yeah.
Big question, sorry.
Yeah, no, that's okay. That's all right. It's become a big opportunity, big part of our business. But if you look at materials in general, everybody knows. People are looking for higher speeds and high-speed digital, and they're looking for lower loss in RF applications. The Internet of Things, also even data communications and those types of things, car electronics, radar, self-driving cars. All these things need low-loss materials. One of our challenges, and again, it's an opportunity, is as a supplier to the industry, is having the right stuff available for our customers. And certainly the Bay Area, it's always been a quick turn market, but it's the time window has shrunk. And one of our challenges is supplying all these different materials to our customers. And of course, with every laminate system, every resin system, you have the different core thicknesses, the different copper weights, and then you have the prepregs with different thicknesses and resin contents. Add to that, also spread glass is becoming very popular. I'm sure most of the people who watch this will be familiar with the spread glass systems. They have electrical and fabrication benefits, but again, it adds to the part numbers, the variety of materials we have to stock. So we currently have here in San Jose, we have 175 rolls of prepreg that we cut for our customers.
Crazy.
Yeah,
Wow.
it's really it always seems like our customers need something we don't have in stock. It's that one thing they need, for that application. But we try and up our game here and have the right things, and that comes from going to our customers and talking to the people in their design group, in their sales department, and asking them, what do you see? Years ago, we used to work on forecasts. Customers would have a very predictable usage on materials, and they'd have forecasts out, for some time.
Yeah.
We would base our stock on that, and we do forecasting today, but it's not the same thing anymore. I mean, customers may get an order, and they have 4 days to turn it, and they don't know what the build's going to be until the stack up's done, and that creates those challenges. But we try and improve what we stock and what we have here, and get better and better at that. It's just it's never boring, that's for sure.
Yeah, right. You got to have a big crystal ball. Yeah.
Yeah. But just to talk a little bit about spread glass.
Spread glass. Now, that kind of puzzles me in context of high speed. So I'm curious. Teach us about spread glass.
So there's different kinds of glass, what they call standard E glass, and then of course the low dielectric constant glass. I'll talk a little bit more about that in a few minutes. But the spread glass is basically that the fibers, instead of having a crossover and a weave like you would in a fabric for like clothing,
right?
The actual filaments in the weave are spread out. So you don't have open areas and crossover areas or areas of higher density glass. And that makes the system more electrically uniform. So when you have traces that go through the PCB, they're not either going through high resin content areas or high glass content areas, because they'll have different signal properties. So you want to make it more uniform.
Are they more in glass spindles? Are you saying it's not woven?
Well, it is woven. It is woven, but instead of having a high concentration of glass with open areas of just pure resin, the filaments are spread across. So you're filling in the open areas.
Okay.
So the bundles
they're kind of fanned out, you're saying?
Yes, exactly.
Okay, I got it.
Exactly. There's different terminologies. There's mechanically spread. There's there's flat glass, but basically what ends up happening is the crossover areas where you would have what we call glass knuckles.
Right.
They're thinner.
I see.
And of course, the open areas now have some glass. So again, the system is more uniform. It's a composite, right? So the composite's more uniform, and that has, like I said, that has signal benefits, especially for differential pairs.
Yep.
If you had one trace in a diff pair running over mostly resin and one running over mostly glass, they'll have different propagation velocities, right? So you'd have different electrical results. So the spread glass is better for that. It is better from a drilling standpoint, for either laser or mechanical drilling, because you're not going through high concentrations of glass where the crossovers are. So there's a benefit there. There are some caveats, though, to how it works with like filling ground planes, because the resin doesn't easily move through the glass fabric. You could have some problems filling. So we have to offer not just the spread version, we have to offer the standard versions as well, because very often designs, if they're strip line, you'll have a reference plane on either side of a signal, and those reference planes could be heavy copper, and they require a certain amount of fill. So you need the standard fabrics to use as well in the stack up. So you will have very often a mixture of those types of systems. So yeah, it does add some complexity.
So now we're not only doing hybrid materials, now we're doing hybrid prepreg.
Yeah.
You're saying?
Well, there are different varieties.
Well,
of
I mean, I guess you have to do it that way anyways, because if you're doing hybrid, you're matching the materials to the bond ply that you're using anyways, I suppose. But now you're adding in this kind of third layer almost of
right, yeah,
glass construction.
And then we also have standard copper foil, and then we have HVLP or VLP copper, low profile coppers. So it adds, and then of course all the different copper weights, really everything from 5 micron through 4, 5, 6 ounces. So it's all over the place, but yeah, actually going on the hybrid thing too, we are seeing a lot of mixing the resin systems. In other words, you would never mix B stages in the same layer. In other words, you wouldn't have one kind of resin melt, but you can mix cores. So you could have one type of resin system, as long as it's fully cured, adjacent to another kind of resin system. And we see that with RF, because very often what you do is you have your low loss layer on the outside, and then you would have your, whether it's high-speed digital or just DC, you would have that in the other layers, and and that system would be mixed. And there are challenges there too, even if you're not mixing the B stages. Some materials require higher lamination temperatures, and if you're not using a standard material that can withstand that, you would have issues, or you would have to use a low-loss material that has normal laminating temperatures. And typically when we say normal laminating temperatures, we're talking in the 375 to 400 Fahrenheit range.
Right.
Whereas some of the more exotic PCB materials,
like PTFE or
the filled PTFE systems, LCP,
LCP
FEP, they require much higher laminating temperatures, more like 550 to 600 Fahrenheit. So
for a while I was at an RF. It really never took flight, but I'm sure you remember not too many years ago we got on like the fusion bonding bandwagon. We thought that was going to solve all our problems, but I remember being at a shop where I think we were running our lamb press at like 700-800 degrees Fahrenheit for 12 hours with some crazy profile. That's not very sustainable, but it was a homogeneous decay, and it had some great performance benefits, but it really never took flight. So my gosh. So let's talk about hybrid a little bit more, because I left the industry for a while to raise kids, and when I came back, it was like Rumpelstiltskin waking up to all this high-speed stuff, and I was like, wow, and what I did see was an awful lot of hybrids. So can you talk a little bit about what you think, sort of, certainly RF and microwave is an obvious one, but talk about what is driving the demand of high-speed digital, RF, and hybrid technology overall.
Well, it's in very broad terms, it's about electronics, doing all kinds of different things.
Right.
From a design standpoint, though, it's about mixing material properties, right? In composites, that's what you do, right? You choose one material over another because of its properties, and you separate those layers out to get what you need out of a design. Some of it's driven by cost. Some of it's also driven by how you would fabricate. In other words, if you had a material that was hard to laminate, you could use that as a double-sided low-loss layer, and then bond the other layers conventionally that would run the DC or other signals you would have on the design. We do have some new materials. So, one thing I didn't mention earlier is that we distribute for both Isola and DuPont.
Okay.
Isola does have a suite of laminates that are low loss, some of them even with decays close to the Teflon range, and they laminate at normal temperatures. So,
wow.
making a composite build, is a lot simpler. You don't have to do two separate laminations, unless you had buried microviews. But yeah, you wouldn't do it because of the materials. You would do it because it's for the design. Right. But you can do that in one lamination cycle. So that's one thing we're trying to bring to market, and that's something that's been a growth item for us. As some of these new materials, iTerra MT40, for example, the Astra MT77. Astra has the lower dielectric constant, so at a dielectric constant of just under 3, that's for certain RF designs, whereas the iTerra is for the mid DK, what we call the 3.4, 3.5 DK range. Okay. But they're both low loss, and they both laminate at normal temperatures. So that seems to be gaining some good traction.
How do they stand up cost-wise against some of the traditional high-speed laminate providers?
Well, as a resin system, PTFE is expensive, and then if you're reinforcing it with ceramic or fiberglass, that adds cost as well. So we actually stack up, no pun intended, pretty well with the PTFE-based products. It's not as well known. Many of the designers are familiar with the PTFE-based laminates for RF applications. So they go with what they know very often, until they have a need, right. And then they start looking at alternatives. So and there's so many different projects coming on with our customers. We're quite busy trying to keep that education process going.
So I'm putting myself in a designer's shoes today, and I was talking actually to Lee Ritchie yesterday, and he was talking about how the speed curve has gone up near vertical in the last 5 years, and I think you and I would both agree that we've seen that trend. I'm putting myself in a designer's shoes, so how do I get educated fast enough to keep up with all these moving pieces? Because I know, like I said, when I left the industry and came back, it was complete waterfall as far as onboarding all the different laminate manufacturers, and then learning about matching bond prepregs and bonding systems and copper weights, and then let's just throw in that we might have this on an aluminum carrier or whatever. How can we do a good job other than hosting a podcast?
Yeah. So I
get people educated.
Yeah. So I think the IPC design councils are helpful for that. Some of our folks have presented. I presented. Other people have presented at those. Mm-hmm. Certainly, if you're an OEM or a designer and you get boards from a board shop, reach out to the board shop and say, what are my options? The board shops have to live and breathe this stuff. And certainly, folks like myself and folks at DuPont and Isola will also support the board shop in that effort. In fact, that's becoming a bigger part of what I do. Is I travel with my customer to their customers and talk about their options, and the pros and cons. Because, you would think in theory you would want the highest performance at the lowest cost, but
not necessarily.
I was to say, well, it's not just signal performance. It could be mechanical performance. It could be thermal performance, right? There are a lot of different attributes that you would need in the design, and you don't know unless you talk, unless the designers are talking to the folks that have the materials background. You can't put all that together. And I've seen projects where people have used the same old stuff, and then they get unexpected results. And so that's what we're trying to do. It's better for everybody if we hit it right the first time. So. That's what we do. Is we go in and we say, these are the options. This is when you use spread glass. This is when you use standard. This is when you go for the lowest loss possible. This is where you go for better economy. We have a material called iSpeed that's very economical, and it's pretty low loss. It's a 006 loss tangent, and it's not as cheap as FR4, but it's close. It's closer than a lot of the other materials out there. And so it's a nice scale of economy. Now, it's not for every design, but those who've been using FR4 for a long time and want to upgrade to a lower loss system, it might be a good next step. And that product actually has been growing pretty well for us. The 4-way HR, the iSpeed's been growing pretty well, and then the high-end products are growing pretty well. The products in between, not so much, but I think it's just a matter of what people need in the design.
Right, that makes sense. Does Insulectro and or DuPont and Isola put out resources online that designers can get a hold of?
Yeah, both companies, obviously, all three of us actually have websites with links to connect, slash sheets, tech data sheets, and other things. But I don't know if a website will ever be a good substitute for actually having a conversation with someone who's knowledgeable. Certainly, that's a good place to start. The other thing too is sometimes a design will have some IPC slash sheet numbers on them. The specification sheets for different materials. And sometimes you're locked into that. So we see that with our customers. Sometimes they're locked into a particular material set, and it may not be the best. And again, that goes back to having a conversation with the people involved. And sometimes they're willing to change, and sometimes not. Sometimes they have no choice. Certainly, old legacy military designs are examples where people are really they're stuck on very old systems. And there's definitely a better mousetrap in those cases.
Right.
Yeah, but like I said, there's no substitute for having the conversation. So.
And I'm assuming that Insulectro, well, I know Insulectro, for instance, we were just at IPC Apex, and I'm sure, Chris, you were doing presentations there. I assume that going to trade shows also, there would be opportunities to have face-to-face conversations.
Yeah, certainly, seek out if you're buying boards, seek out your PCB shop. The folks at those trade shows, or sit in on some of the technical sessions, and then certainly, if Insulectro, Isola, or DuPont are there, great place to go get some information on materials.
Oh, great. Well, I know I sound like I repeat myself often about this, but I've often said, and I used to blog on Microwave Journal to tell people, please go talk to your board shop, please go to your board shop, because I think it kind of all ends and starts there, and because, like you said, they have to deal with so many laminate and resin systems and all these things every day that a lot of time they could be helpful. It's just sometimes I think designers are so strapped for time. Sometimes they're doing the jobs of two people, and so I'm always trying to help the designer get resources as best they can.
Yeah, and it's something we appreciate. And what we see happening too is they'll pick up a data sheet and they'll look at different. Sometimes there are very minor differences between resin content and electrical performance. In either the dielectric constant or the loss, and they'll pick the lowest on the data sheet, but that might not be the best for the fabrication. And having the right material to make the board come out right, yield well, do well after assembly, do well in the field, you're not really giving up anything. I mean, even if the loss is, very, very, very minor, higher in loss, but yet the board performs well, it's definitely a good trade. And so that's part of the problem is some of the designers who are pressed for time, they'll pick a particular material set that it might have the lowest numbers, but it may not be the best best for fabrication
overall, right?
Right, and if you can't build it, or if the board shop doesn't yield well, it doesn't do anybody any good. So. Well,
I was just talking also to Kelly Dack. You know Kelly, Chris?
No.
Kelly Dack is. You'd probably recognize his face. Anyways, we were just talking about this, and it's like what looks good on paper isn't always the best thing. It doesn't. It's not always this linear process when it comes to design and fabricating. So back to the hybrid designs, what would you say for someone that's designing hybrids, some of the challenges are of those boards and some of the benefits? Obviously performance is one of the benefits, but
performance and cost, because very often the very low loss materials, come at a premium, because of the resin systems, the cost of the resin systems, and the cost to make the materials, and so on and so forth. So that is another benefit. It can be a challenge for the board shop, and it really depends on the materials. really the challenges are more often in fabrication than they are in the actual design part of it. Like I said before, it just varies so much. I mean, one of the requirements usually for an RF design is to have a certain level of precision when it comes to forming the circuitry. When we say forming, it could be plating and etching, it could be just print and etch, depending on the technology used, and then you would laminate that into a standard FR4 system, and sometimes those materials aren't real compatible. So again, that goes back to being able to have materials that have the right CTE properties, the right adhesion, the right lamination, properties. But
you look at some of these high-speed materials, and sometimes they can be more fragile. I mean, they might, for instance, and correct me if I'm wrong here. This is secondhand knowledge here, but they might survive the fab process okay, and lamination cycles, or even multiple lamination cycles, because then you introduce buried and blind visas, and then there's multiple thermal excursions, right? And then you take it to assembly, and you've got through hole and surface mount part, and they have to go through another 2 thermal excursions, and so that all adds up, and it's not obvious on the outset, right? To factor some of that in.
Yeah, those are all good points. All things that have to be considered in the fabrication and use of the part. There's a lot there too. One of the things I'm seeing is copper is a really good moisture barrier. So one of the things that we try and preach to our customers and their customers, or the assemblers, if it's a CM, is you have to bake the parts prior to assembly, and you can't underestimate that. There was a really good paper put out around 2011, 2012 at IPC that showed just how long it takes for the moisture to get around, because if you have strip line construction, or if you have a reference plane in RF design, the moisture's got to go around that copper plane. It can't go through it, and I've seen people underestimate the baking and end up with scrap for no. It's kind of a shame, because if moisture is the only reason why you're delaminating at assembly, it really is avoidable. Yeah, sometimes it's a pain to bake a board for 2, 4, 6, sometimes 24 hours. Yeah. But if that's what it takes to yield well, it's still worth it. And that's something that comes up a lot.
Well, I know that I work for a smaller RF shop, and we had the case where we were doing kind of pre-production quantities, and the board was cooking along, no problem. And then one day, it wasn't working. Guess what? It had rained for a week.
Oh.
And we didn't have them like in an airtight storage or whatever. So we had to completely look at the way we were storing and make sure we were baking. Just because in California it doesn't rain that much, and it wasn't, first and foremost on our brains. And it was like, when it came down to that, it was like, what? Didn't see that one coming at all.
I've seen that happen. Yeah, I've seen that where customers or assemblers, they don't bake for years and think everything is great, and they want to know what's changed. And it's like, well, material's the same.
Had a heavy winter.
It turns out it was something like that. It was, it's always best practice to bake, and it varies so much by design. And again, ground planes are a problem. And in fact, there was a great study done at recently with HD Pug on, and I don't know if your listeners are familiar with HD Pug.
But maybe not, but we'll share that link below in the show notes, because they're an amazing asset to our industry. So
they did a great study on crosshatch ground planes on flex. So there's some performance trade-offs with crosshatch ground planes, but they do create window moisture to get out. Moisture will get in more easily, but it can get out more easily, and as opposed to a solid plane. And there is a frequency cutoff where that is usable. And one of the things the study looked at was diamond-shaped versus round openings in the ground plane. But I always like to put or recommend putting openings in the ground plane when you can afford it, just as a moisture egress.
That's new to me. That's so neat, but it completely makes sense, right? If you're locking in moisture inside of the laminate because you're capping it off, you're trapping it. right?
Yeah, and a lot of the PCB processes are water-based or aqueous-based
Yep.
chemistries,
Sure are.
even up to the surface finish. Enig, one of the most popular surface finishes, it sits in a hot bath
Yep.
for 30 minutes. Actually, two hot baths, the gold bath and the nickel plating bath, are high temperature. Like 180 Fahrenheit, 190 Fahrenheit for 20 or 30 minutes in each bath. That's a big opportunity for moisture uptake on the part. And if you can imagine, that's near when the part's finished. It usually gets routed and cleaned and a few electrical tests, a few other things. But then it goes out to the company that does the assembly. And if some assemblers require the board shop to bake, which is okay.
Right.
If you put it in a moisture-proof bag, but even that's not a guarantee because the board shop loses control over, when it was opened and how long it stays in the atmosphere before it gets assembled and so on and so forth.
Or just before it gets bagged.
Yeah.
Right, and
yeah.
Or it may already be present and you're just vacuum sealing a moisture-laden board. It's so many moving pieces. I always say, I wish my dear friends that were printed circuit board designers or engineers that are designing boards now understood the complexity of board manufacturing, because and just let's talk. I mean, you and I have been talking this whole time about just the laminates. This is not drilling, laminating, buried or blind vias, filling vias. Like there's so many moving pieces, and I think sometimes
copper foil bond treatments.
All of that, and I think in this day and age, a bare board is a line item on your BOM. It's not like pulling a component off the shelf. And so I think the closer board fabricators and engineers can get together, I think better for both, actually, because sometimes I think the board fabricators sometimes also get exasperated with designers, but the technology is being driven in a certain way, and they're going to be the first ones to see it and can actually help enable the board manufacturers in many cases. So it kind of goes both way.
An experienced designer will know what the board shop needs, and that comes through communication. Things like minimum clearances, design for manufacturability, those types of things.
Yeah.
And all the board fabricators I know are very good about working with their customers. To try and again, it's in everyone's best interest to yield well and have a part that survives.
Absolutely. Absolutely. And back to Kelly Dack, we had a long conversation. Actually, two people here at Altium, all of our AEs and FAEs here are required to take the CID course. And so two guys here recently took it. And so for the first time, I got to look through the workbook. Holy cow. This thing is like this thick. And a huge percentage of that is the DFM things. It's understanding. So to hopefully save time and money and headache, on the end of the designer. So, well, Chris, I know we've only got started, but we need to do this again, clearly.
Okay.
Because the other thing I want to talk with you about is Flex, because Flex is on the rise. And I know you'll have a lot of insight there, and I would love to ask you more about that. But before we go, I always do this thing at the end of the podcast called Designers After Hours, because most people in our industry usually have some kind of interesting hobby, or I don't know. A lot of us, even though we kind of act left-brained, we have a pretty active right brain too, actually. So sometimes we're creative or do something interesting. So do you have anything that you enjoy doing after hours that is sort of unique?
Yeah, so actually I've been diving since the late 70s. So when I was living diving.
Diving. I thought you said dieting, and
no,
I'm
no. I don't dive.
Scuba diving. Okay.
Yeah. So I started back east when I was living in New Jersey. I actually did some shore diving and some wreck diving, and that was a lot of fun. Now in California, when I was living in Southern California, was Catalina Island and the Channel Islands and so on and so forth. Here in Northern Cal, the best place to go is Monterey. I've done some abalone diving up in Mendocino, but that's free diving. That's not scuba.
Right.
Yeah, no. In fact, I've taken my sister and my niece. They're divers also, and we've gone down to Monterey and have done that. So that's one of the things I like to do. It's something I don't get to do as often as I like.
Of course, I know we're all so busy.
Yeah.
Well, speaking of free diving for abalone, my mom and dad grew up here in San Diego, even though I grew up in Orange County, just about 2 hours north of here. But my mom, when she was a teenager, used to free dive for abalone in La Jolla Cove. So about a year ago, I moved down here, and I'm itching to go get certified and do diving here because there's some really neat dive spots here. But we went to the area where my mom actually used to free dive, and my daughter came up from snorkeling one day and pulled up 2 abalone shells.
Oh, yeah.
Which
You'll
is
see
so
the
rare.
shells. Yeah.
Well, but down here it's so picked over.
Right.
Because it's like there's divers out every weekend, and so it's really rare to find, I think, live abalone anymore. But she brought up a couple of shells. So
Interesting fact about La Jolla, you can find electric rays down there.
Really?
Yeah, so rays that are capable of delivering an electric shock, yeah.
No way.
Google it, check it out. Yeah, they're pretty cool.
Okay,
Yeah, don't touch them. Don't touch them, but no, they're pretty cool.
Yeah,
so,
that's where my interest in electronics and nature stops. Well, thank you, Chris, so much. This has been fascinating, and I want to ask you 50 more questions. But if you will say yes, we'll do this again in a month or so, and we'll talk about Flex and learn from you there.
Sounds great.
Okay, thanks so much, Chris. Again, this has been Judy Warner and Chris Hunrath with the OnTrack podcast. Thanks for joining today. We look forward to for you tuning in again. And until then, remember to always stay on track.